Margarine is basically an emulsion of water in fat, resembling butter in appearance, character, and composition. The fatty phase is normally a mixture of vegetable and/or animal oils and fats, and the aqueous phase skim milk or water, or a mixture of them. Small quantities of other ingredients, such as salt, flavors, and emulsifiers, may be incorporated through either of the phases. There are various types of margarine for specific applications, of which the most popular are table or tub, industrial, and pastry margarines. Margarine is universally formulated to contain 80% fat and 16% water. A number of other ingredients, either water or fat-soluble, may be added to impart taste, flavor, and aroma, and to enhance its physical, chemical, and nutritional properties. Water-soluble ingredients include salt and preservatives, while fat-soluble ingredients are emulsifiers, lecithin, antioxidants, flavor, natural coloring compounds, and vitamins. Manufacturing process. Ingredients such as salt, emulsifier, coloring agent, flavoring agent, and antioxidants are weighed accordingly. This is normally done at 60 to 70 degrees Celsius. A homogeneous melt is ensured by continuous stirring in a mixing vessel. The water-soluble ingredients are dissolved in a small volume of water made up to the final volume, which constitutes 16% by weight of the margarine. The mixture, or the aqueous phase, will be added to the fat phase. Emulsifiers, such as mono and diglycerides, depending on the type of margarine, and lecithin, should be first dissolved in a small volume of the oil and fat blend, preferably in the ratio of 1 to 4 at 65 degrees Celsius to 70 degrees Celsius. The mixture is then incorporated into the main bulk of the oil and fat blend in the tank under continuous stirring at temperature ranging from 50 to 60 degrees Celsius. Other fat-soluble ingredients, such as antioxidant, color, and flavor, are dispersed in a small volume of the fat blend and mixed into the main body of fat. This is also done at 50 to 60 degrees Celsius under continuous stirring to homogenize the mixture. The mixture of fat phase is now ready for mixing with the aqueous phase. The prepared aqueous phase is incorporated into the fat phase under continuous stirring at a controlled temperature of 50 to 60 degrees Celsius, forming into homogeneous water-in-oil emulsion in the emulsion or mixing tank. A temperature between 10 to 22 degrees Celsius and a scraper speed of 300 to 1000 RPM are maintained in the pre-crystallizer. With the big temperature drop, crystallization occurs rapidly. Time is required for full crystallization, and the pin worker allows the margarine to do so under agitation by the rotating pins. The rotating pins help to crystallize the pre-crystallized emulsion and homogenize the fat. The margarine is collected from the pin worker and packed in different forms, depending on the type, product consistency, and consumer preference. Tempering at 5 to 7 degrees Celsius for 24 hours stabilizes the texture of soft-type margarine. Higher temperature is needed for enhancing plasticity of baking and pastry margarines. Tempering at about 2 degrees Celsius above the melting points of these margarines for more than 24 hours is normally carried out to obtain margarines with good plasticity. The right packaging material and transportation temperature are crucial factors in the quality of the final product. Advantages of using palm oil and its products. The crystal form in margarine greatly affects its texture. Palm oil imparts a very high stability to the better prime crystal form, which promotes plasticity. Palm oil is naturally stable with a balanced composition of unsaturated and saturated fatty acids. This allows manufacturers to tailor-make margarine formulations. Palm oil also contains 10% linoleic acid, which is an essential fatty acid, and lacks linolenic acid, which causes flavor reversion. Palm oil is naturally semi-solid, so it doesn't need hydrogenation in solid fat formulations. Hydrogenation is not only costly, but also produces trans fatty acids, which is a health risk. If need be, the solid's content can be enhanced through direct blending or interestification of palm stearin, available in various hardness or iodine values in the market. Palm oil and its products can be used either as the main ingredient or base stock, having the ideal characteristics for margarine manufacture. The wide range in its natural solids content makes palm oil the most versatile raw material, unlike liquid oils, which requires hydrogenation, and in turn forms trans fatty acids.